Well, now let's look at an interesting, even if simple application, and it's actually quite interesting because we are looking at the Indian airline route map. So you have such data from websites such as this. So there's an open flight data which gives you like a ton of data where you can just pull the Indian, you can filter to the Indian data and so on. Okay, and it gives you a number of things. It gives you the name of the airport, the city, country, of course, then what is the IATA call sign and so on, and what is the IATA abbreviation for the particular airport and so on and so on. Right? And most importantly, you have the latitude, longitude, altitude, time zone and things like that. What's most interesting is that you can now use this information to actually plot this visually, and let's see how to do that. So here you create a graph, and basically for every row you can just fetch all the columns, so you know what is the node ID and what are the other attributes like name and city and so on. So let's just pull this information. Okay, wait, I didn't run this. I'm just printing a random node. Okay, so let's also see. So there are so many different nodes. So let's just look at the node list. Yeah, so these are your IDs 2994, 2995 and so on, right? So these IDs are how you can, so let's look at. So this is a particular airport, and what is its latitude, what is its longitude and so on. You can also read it as a pandas data frame, and you now add all the edges and you print a random edge here, and let's just remove orphan nodes. So there are so many such airports which didn't have any information out of the 139, so they are now removed, and now let us plot it. So if you see, you can get the position based on longitude and latitude from the node list. Just look at this code carefully. It's fairly simple, but I would like you to take a closer look at it and then tinker around, and let's just make a plot, and here you go. So here we've given every node size as the same, and so can make it a little smaller, let's say, okay, little smaller, and but you can see this looks pretty much like an India map. You have this Andaman Nicobar, Lakshadweep and so on, right? So you really see that, and you can see that there's probably a little bit missing here because of the desert regions which won't have an airport and so on. And you can see that this is a big hub, no guesses what this is, and so this is going to be obviously Delhi, this is going to be Kolkata, this is Chennai, Bangalore and Mumbai. It's pretty obvious, the the airports, the metros just spell themselves out. Okay, so but now you can start visualizing, right? So, we will see this in future classes in terms of various properties, but degree is the simplest property which you will already know, which is essentially the number of edges that emanate from a given node. And here it is. So, we size the nodes appropriately to scale and then plot it. So, node size is for every list, for every node, and we take its degree from this list, and maybe you just want to quickly see how that happens. Let's just look at rg.degree. Here you go, right. So, this is a dictionary and you can convert this into a list, and this gives you tuples. It tells that 2997 has a degree of 44. You want to see what is 2997? Mumbai, right. So, that has a degree of 44. Okay. So, now we are just multiplying the degree by 100 to really get some sizing going. You can obviously have even like non-linear sizing, but I think linear sizing is more understandable for us. But sometimes in other graphs, when some degrees are like really large, you want to basically cap off the top degree or the top size, because you don't want like the whole thing becoming a a big blob. So, let us just do 1000 and you will see what I am talking about. Yeah, this is really not useful. And this is good but not great, but maybe somewhere in between you will actually get, yeah. So, you have good clarity here. So, there is a good gradation of sizes, but you may want to just cap off sizes, and again you can see the metros screaming out loud here. Okay. And you can also color the nodes based on degree centrality. So, for certain nodes alone, so you do like you actually do a color map here, and basically across so low degrees have a blue color, and higher and higher degrees have darker colors, I mean various colors, and you can see that the highest degrees have red and so on. And you can also try to visualize the edges. So, here this is a concept called betweenness centrality, which we will cover in a future class, and what this tells you is you can overlay these edge properties which can be computed using NetworkX, and you can see what is the most important connections, right. So, there are some of these connections that are really important because they connect you to the periphery and things like that. So, this essentially tells you how often you need to take this path if you have to go between two nodes in the network. So, this is also a very, very useful way to look at these networks. So, you can visualize these networks in so many different ways depending upon your own creativity and what you really want to model and capture and understand. And here are all the tools that you need to do it. So, you can compute edge widths based on some centrality measure and then force it on your plot by using nx.draw. I would like you to tinker around with this notebook a little bit more and see if you can come up with better visualizations, more complexities, and so on. Okay, and see if you have other data sources or other interesting networks that you can visualize, and this will be a very interesting exercise for you. Okay, with that we come to a conclusion for this basic tutorial on NetworkX. I hope you've now understood quite a few concepts on NetworkX, and this will help you build various kinds of graphs from either adjacency lists or edge lists or adjacency matrices. So, probably the best way to do it is an edge list. It's going to be widely available. If you, for example, go and look at a string database, it will give you an edge list for any organisms, protein interactions / functional associations. And you can start working with that. You can start visualizing them in different ways. Of course, if they are really large, you may not be able to visualize them directly in Python. You may have to maybe not visualize it. You have to be content with looking at degree distribution plots and some top n nodes kind of statistics, like what are the nodes with the highest 100 degrees and so on. or you can filter those networks to the neighborhood of an interesting node, or only like very high confidence interactions by eliminating those with very low confidences. There are these string scores that we will talk about in a future class. So how you can basically filter out those with low and medium confidences and so on. It essentially prunes the network so that you have a more tractable network with acceptable density to work with. Okay. So just to quickly recap, we also did a bunch of installations. We needed a few tools here. We needed NumPy, Pandas, Matplotlib, NetworkX, SciPy, and so on. And we looked at how you can create various kinds of network, various kinds of graphs. So undirected, directed, multi-graph from an adjacency list or a Pandas data frame. And we can also export these. You should look at it, and various other data types that exist. And you can look into nodes, look into the edges, get the properties. They're all dictionaries, so very versatile, very easy to work with them. And we also looked at what kind of how do you look into the edges and what happens when you don't have an edge, and so on. You can always check, right? So for example, instead of doing this, the correct way to code this will be and if I now set this, we have a different G here because we've run so many other things, but let's just see 1, 2 G dot edges is true, 1, 3, let's say 3, 2, and that is also there because this is an undirected graph, right? So let's just this is a graph and not a digraph. Okay, so you can see the versatility. And here are the various graph types. We just looked at the same edge list, a very nice example where you can look at it, what happens when it's an undirected graph, directed graph, multigraph, and multi-digraph. And we looked at how you can draw, change the node color, edge width, node size, and ultimately load a real world data set and visualize it very nicely. Simple visualization, but then overlaying sizes for the nodes and also for the edges and so on. So I hope you now have a much better introduction to NetworkX following the quick presentation I did earlier. And now that we've actually done this hands-on using a tutorial, you have this notebook accessible. So please tinker around with this notebook, try a few things, download a new data set, play around with it, post some nice images, and so on. I'll see you again, and we will look at, we will go ahead with other concepts in network theory, right? Various kinds of network centralities and so on. And we will also do future tutorials where we will look at network models, network centralities, and so on. See you.